so we looked at kind of one-way things of just relating the movement to a function. But the more interesting version of using expressions, in the same way that we let these new attributes talk to the expression also lets you build these sort of virtual connections between objects. As long as you know the names of the objects, you can connect them via an expression. So what does that mean? So starting with a sphere and a box. What I can do now is I want to link the up and down motion of the sphere to the rotation in the y of the box. Yeah? So how do I do that? Again, I'm going to call this one box and this one ball. So what I'm actually going to be influencing here is rotate y of the box. So again, I'll show you another trick here. We can click on the expression under there, but if you're starting fresh especially, I can also highlight the attribute and say, where is it? Oh no, that's not true. Let's start again first. Ignore what I just said. We go to the expression editor, and what are we wanting to control? We're wanting to control box dot rotate y, and the capital does matter, but just to make your life a little easier, only for the sort of simple built-in attributes, translate, scale, rotate, there's a shorthand for everything. So rotate y, you can actually just write ry. Or for translate, you can just say, like translate y, translate x, translate z, and it does it. It only works for the kind of really simple ones, but sometimes it's nice just to do it in the shorthand. So I'll do it this way. So box.ry, I'm going to say that is equal to ball.ty. So now, when I move these, yep. So again, what it's saying, left is always controlled by the right. So, I can no longer go in and just set this to a value myself. It'll say, sorry, that's already being controlled by something. Because what it's doing is it's just a number, right? So it's taking 4.345 and saying you're equal to 4.345. Yeah? But luckily, again, these are all just names and attributes, but they are numbers, right? Or you can treat them as numbers. So I can do anything to it I want. So I could say, times 50 or times 20. Yep. All it's doing, take this value, 6.543, multiply it by 20, connect it to here. That's it. Well, what's interesting is it starts to free things up for us a bit, that we can start to make these sort of proportional connections that don't have to be mechanical, right? Like you're going to have to make something that transfers vertical movement to rotation. You just assign it, right? Like this is how much each of these mean. And this is kind of one of the important things we start to look at going forward, because now we start to talk about what we're going to be talking about with the physical stuff, which is just calibration, right? What are these ratios? What makes sense? You know, is this connection correct? You know, does it make sense to be 20? Don't know. You know, does this work with my movement? You know, here as well, just like before, I could also, instead of just writing 20, let's call it ROT factor again. And by the way, you'll hate this little bar of red until you get used to writing things. Of the wonderful thing called syntax error. You'll love it. So it says expression invalid after edit. Here's why. Because I wrote ball.rot factor and that doesn't exist. It's actually box.rot factor. So now, just as before, yep, it's just, you know, setting up the dynamic system, and especially we'll talk a lot more about these. Like once these things start getting more complex, you know, you start basically just building little control panels for these, right? You know, what are these sort of factors so you can kind of quickly go through and calibrate all these relationships. You know, one thing to see is just in terms of looking at the interface. You know, I want to be able to mess with that factor, and it's kind of a pain to go back and forth. So I really don't want to use that one anymore. So I'm going to make this one, add an attribute here, and call it ROT factor. See? So I'm just basically changing where it's looking. And that's totally just for usability. It doesn't matter. I mean, you could have the factors on any object. As long as you know the name of the object and the attribute, it doesn't matter where it is. So now it's not doing anything. So you know, you can kind of on and on, you can go on and on with these things. Let's say, for the sake of it, by the way, you'll see me do a lot of copy and pasting. I would recommend the same. The more you copy paste, the less likely you are to mistype something. So I know I want to do something with box. I actually just want to then do ty. So I'm going to copy paste it. So I'm going to say that equals ball r z times 2. Yep. And I mean, the beauty of this is, I mean, this can kind of string together as much as you want. The basic parameters are this, though. For right now, although I'll show you the possibility of of how this is possible, but one attribute can only be controlled by one thing, but one attribute can control many things. Here's what I mean. So right now, translate y is controlling the rotate x of this. It's also, let's say, going to control ring dot, I want to say ring dot scale. Right? So, I mean, you can have one thing that, like, if you look at the diagram, right, like one output, you can plug it into as many things as you want. You just can't plug two things into the same outlet. And again, you know, what we were looking at before, anything can be connected because it's all just a number. So, let's say, you know, I wanted to, instead of just adjusting the scale, I wanted to deal with the sort of radius of the torus, right? So how do I figure that out? I change the value. I look in the script editor. That object is called polytorus1.radius. Yep.
If you change the scale of the torus, will it change the position of the circle?
No, one-way relationship. Everything, even though it's not, it's still, you can think of it as a sort of parent-child or controller controlling. It's not, like, everything in these things always happen in like one directionally, just because they're meant for control, not for fiddling around, unfortunately. Like, everyone wishes that it was just a kind of dynamic link between the two, but like everyone always kind of, when I was taught this stuff, it was like, the guy joked about it, like, it's always parent-child, it's never like the kind of consenting adults relationship, it's always parent-child. And these things can kind of go on, and then to show you some, so this is one, we'll make another one over here. So I'm going to do something a little bit different. We haven't talked about, we haven't talked anything about materials or rendering, and we won't talk about materials or rendering, or we won't talk about rendering. So, but I'll show you, in this case, I'm going to go rendering editors and Hypershade, which is just means material editor in Maya. So I'm going to make a new material. I'm going to make a blend. It doesn't really matter. Double click it. And it comes up here. Change its color. I'll make it red. Pick this thing, and then hold down the right click and say assign material to selection. And I'll also, well, do this first. So that's great and all. But what I'm going to do now is basically turn this thing into a color tuner, right? So using this box, we're going to tune the color of the sphere. So to do that, before, just like we've done as a little trick in the past. So, when I change the color, and I said it's fine. So to get there, it's a little bit trickier on this because you can do things with the script that you can't do with the expression editor. So it's the name of the material is called blend1, and then it's just .color. And I am going to start there. So I'm going to copy that. Actually, before I do that, I'm going to change the name of this to color input. Why? Because it's going to be a color input. So blend1.color, but as you know, colors generally described a couple different ways, right? RGB or CMYK. Since we're working on screen stuff, it's going to be RGB. So what I'm going to do here is just because I know it, I know that it's called color, blend1.color R. I'm going to say that is equal to color input.ty. But actually, hold on, I'm going to do something before I do that. So what I'm going to be doing is relating the sort of translate values, but obviously it already has its values in relationship to the origin. But basically what I want to do is set up a new coordinate system based over here. So I want this to be the new kind of origin point. So to do that, I'm just going to pick the box and say modify freeze transformations. Yep. So now that's my new 0, 0, 0. And then I paste this back in, hit create. Right? So I'm now controlling the red channel. Then I obviously just need G and P. Again, copy paste, color R, color G, color B. I'm going to switch that. I'm going to say X, Y, Z. Make sense? Mm. Then we edit. So now, we have our little controller. We're going to do something even more fun though. We're going to go back here for a second. Go into the attribute editor to get to our material. We can also talk about transparency. Transparency also happens in RGB because it's the full thing. So I'm actually going to copy this whole block, come down. Transparency. Change this to RX. works on the first try. So what do we have now? So we have right? Because again, if it's just, you know, color is described by number, right? I mean, RGB values are values. And within Maya, any value can be related to any value to make the relationship. So, what do I want to show you next? All right, we're going to look at two more things, and then that's going to be it. Both of them are a little bit more advanced, but hey, we'll come back to it again. So the first thing is, you know, as I mentioned before, you know, if I set up a relationship between these two guys, so in this way, we're going to call it ball and box again. Yeah, simple. So jumping ahead, I previously said, you know, once this is set up, translate Y can only ever be controlled by rotation Y in the other one, right? So we've set up the relationship, that is it, right? You know, this can never be affected by anything else. Well, there's a way around that, which I'm go ahead and showing you because I mean this is one of the advantages of talking about these things as kind of virtual machines, right? Because we can cheat, like things that you can't do in real life, you can do in the digital world. So you can say sometimes I want you to be connected to this box. Other times I want you to say connected to that box, right? So the way that you can do that is you have to tell it, you basically have to write the rules. You have to give it the conditions, right? You have to say, when am I connected to this one and when am I connected to that one? And that all has to live within the same expression. So what I'm going to do, I want to make a switch. This will also help because right now, this is going to be my switch that I'm going to flip. But I don't want it to rotate from here. I actually want it to rotate from the bottom. So to do that, you need to move its pivot point, right? There's a couple. The easiest ways to do it. Well, on Windows, it's if you hit the Insert key. On a Mac, it's function and left arrow for some reason. So if I do that, like you can see, I'm now not moving the object, I'm moving its pivot. But what I really wanted to do is just to snap to that vertex. So I'm going to turn on the vertex snap. And that's it. So, and then to turn it off, I just hit function there again, and now it rotates from there. The biggest reason why you do things mostly with polygons in Maya is because the snaps for things that are done in surfaces basically don't exist. Like, it's terrible. I mean, it's extremely terrible, but such is life. So now I moved its pivot, and it rotates from here. So what I want to say is when this thing is flipped on, this one controls it. When this thing is flipped off, the other box controls it. So how do I tell it that? So what we're really going to look at is this rotation z value of our cylinder. And of course, the first thing I want to do is change this guy's name to switch. So I can switch 1. Because there's probably already something called switch. So switch 1. So what we're going to use as our condition is the rotation of our switch. Yeah? So in this case, if you look just at the value, you can say if it's greater, here's the other thing I'm going to do, just so you know, because I don't want it to get rotated all around and stuff. So that's just kind of a pain. I'm going to highlight rotate X and rotate Y and say mute. No. Lock. Thank you. So now, can't do it.
Rotate in one direction.
Yeah, it'll only ever. The other two are grayed out, so no matter what I do, I can't get it to rotate in that way. So what we're going to say if it's greater than minus 90, this thing controls it. If it's less than minus 90, that one controls it. Yep. And if you've done anything with any sort of simple bits of script or program before, the way you do that is with an if statement, right? So an if is just a simple yes or no question. So our yes or no question is going to be if switch 1 dot, that's our rotate X, if it is less than or equal to minus 90, right? Good old like 3rd grade math stuff, right? Is this number bigger than this number? Yes or no, right? Because it's a yes or no question. It's not, does this number look nice? It's like, is this number bigger than this number? Yes or no? And how that works is you then set up a sort of subroutine using the curly brackets.
Is that X or Z?
It wants to be. I was going to be very confused why that wasn't going to work in a minute. So what it says is, every other time, or previously when I was showing you expressions, it was executing everything in the expression all the time. By using something like an if statement and then these brackets to sort of subdivide it, unless this statement is true, it will skip this. Right? So what I'm then going to do is I'm going to put that, I'm going to take this, cut it, and paste it in here. And now I'm going to Yeah, so that's happening. It's happening. Not happening. Yeah, because it's basically it's ignoring it, right? Like even though it's in there, it's not actually reading that connection because it's kind of embedded one layer down in an if statement. Since we have, I'll write this out the long way first. So what I now want to do is kind of have the opposite of that. So I'm going to copy this. So when it's greater than negative 90, what's that called? It's going to be called box2 now. See? Nothing? Yep. Since there's only, I mean, I went ahead and wrote it out the long way the first time. Since there's only two choices here, I could have also just wrote just because this is either true or it's not. Nothing happening. That's controlling. Yeah, we will, I mean, we'll talk more about this because this, again, is probably a little bit more than what we needed to get into. But how much time do we have? It's 4. Yeah, we'll do one more thing. So, you guys are getting a super crash course in the weirdness of my animation today. So you're going to get a little bit of dynamics too. The dynamics in a really short sentence. You know, so far we've looked at animating the movement of objects by you defining keyframes, you know, other functions, relating it to other objects, and kind of hierarchies. With dynamics, you can basically animate the same values just through physical simulations. So again, we're going to have a plane and a sphere. And I'm not going to go too far into this. We'll talk about it again. But oh God, I can't even see mine. So what I've done is, it's a thing like active or passive rigid bodies, which means, you know, all these, when I go into this, especially this is all yellowed out because I can't animate those values anymore. I can't use expressions to move those values around. All I can do is give it physical properties and forces. So this has a sort of mass, but like 400 frames. And what it basically turns mine into is a simulation engine, right? I mean, it's in the same way you would do, say, like a structural analysis or like a heat analysis on something where it's solving out physical properties. Maya function as a simulation, is a physics simulation engine to just animate stuff. So the reason why nothing's happening when I hit play is because there are no forces. So I want to pick the ball here, give it gravity. Right? The way I change how that interacts with gravity is by changing its properties. So it's something wonderful like bounciness is a great one. So it has a bounciness of 0.6. So if I make the bounciness 1, it bounces more. If you make the bounciness something like 4, it's not coming back. That was a little much. Let's just call that 1.5. Actually, give myself a few more frames. Yep. So, it's now a slightly different situation. So I'm controlling the setup not by changing the values, but just by changing its properties, saying you are more bouncy or less bouncy or heavier, let's say. I mean, the other thing you get into here is, of course, then I did that, of course, because it was really heavy. It floats off because it's not connected to gravity. Like, again, it's digital world, right? Gravity is just, it's a variable, right? Like, you can be connected to gravity, not connected to gravity, flip gravity, rotate gravity. It's all just numbers, which is the fun of it. So I need to connect it to gravity. But back to what we were looking at, I mean, let's say I made a torus over here. Again, it's what I call ball. Was a ring dot. Yes. Right? Same thing. It's just connecting it, but instead of me moving it, it's now just taking the system a little farther, right? It's just a number, but it's like, all right, I'm not going to set the number. We'll let it be set using physical properties. That's enough new stuff. Well, we're going to continue with these things. So what happens what happens for next time? Rather than me talking the whole time next time, we're going to get to see first. I would call it a useless digital machine, right? This is what everybody is in charge of making for next time. It's a useless but interesting digital machine. My example, and it has to work off of this one file that I will send you shortly, which I showed you last time. So, which is this guy, right? So everybody for next time will get the crank, and has to set up their own machine that functions by turning the crank. On mine, this one does this. Oops.
We're going to make that in here next time, or we should have it?
You're going to have it for next time. So basically next time everybody's going to show their machine. Well, you didn't really have the ability to make a good one yet. So.
And it has to be based on that one?
Yeah, it has to be based on whatever you make. The only input you can have is turning this crank, and I'll email everybody the little OBJ file, so everybody has the same hand crank. And I can tell you this little thing, like what I'm showing you here, doesn't use anything more advanced than what I showed you today. I mean, not even the end stuff, like the sort of basic first stuff I showed you. I mean, this is all basic hierarchies and a little bit of expression, and that's it. The one thing I will say that's important to that, because so everybody should have this for next time and have it as a video on the website. So you're showing it from the website. So it's important for me to show you a simple way without learning lots of rendering and things, because we're not going to talk about rendering, of how to convert this stuff into a simple movie. So this one's animated or not? It's not. So this guy, I'm going to keyframe, so we're going to do 400 frames. It's going to go 720. This is a good point. Say then 720. All right, so that's my animation. Turn the grid off because I don't want to see it. So yeah, without doing anything fancy, I just want to turn this into a movie file. So the way that you do that is, oh God, I just had totally blanked out there. Oh, sorry. It's under Window, and it's called a Play Blast. And all that Play Blast does is just like, it's a screen capture. It's kind of exactly what you see on the screen for whatever you set up the length of the timeline to be. Plays it on the screen, converts it to a movie file. Everybody's happy. So you go Window Play Blast, and instead of clicking on the actual thing, you click out here on the little square, which everything in Maya, if you click on the square, it gives you the options. So the very top part is just a question of, what range of time do you want it to do the play blast for? Right now I'm saying the whole time slider. You could also just say start end and say, start at frame 1. This would do from frame 1 to frame 10. So I know I'm going 1 to 400. These when it's making the video, I'm going to unclick view and ornament because it means it's not going to show the kind of name of the camera or the little origin in there. So it's going to be QuickTime. MPEG 4 will be fine. So from window, it's fine. The scale is going to be, essentially if you consider this the resolution of your screen is what it's capturing at. I'm actually going to go at 50% is probably fine. You can also fiddle with that. Then say save to file. I'm going to say save it on the desktop, and I'm going to call it Penguin Machine. And then I hit play blast. Maybe I'll look for it this way. So then I look on my desktop. And that's my movie. Yeah, super simple. And of course, then for the website, you just upload it. I mean, if you don't already have a YouTube channel for yourself, you should have one. So just make one so you can then just link it to the website. So for next time, everybody needs their machine working off of the crank as a video and on the website. So. And